answer this question. Find the sum to infinity of the series if x is equal to 3. We need a and we need the value of r. From the series that we have, do we have the value of a? Yes, we do. The first term is a, but do we have the numerical value of a? No. So what did they say here? If x is 3, find the sum to infinity of the series. So I'm going to go back to my series and I'm going to substitute in the place of x 3. 3 into 3 minus 1. And I'm going to calculate what the value of a is. What's 3 minus 1? It's 2. So that's 3 times 2, which is 6. So my a value is 6. Take it in. Find the sum to infinity of the series if x is 3. Remember guys, I had found what will make the series converge. It's when x is between -2 and 4. And it so happens that this x value, which is 3, is a value that is actually in this interval. So it's an acceptable value to make my series converge. It's an acceptable value. When x is 3, the series will still converge, which means you can find the sum to infinity of your series. Right? So we can get a first by substituting 3 in the place of the first term where x is. 3 minus 1 is 2. 3 times the 2 gives us 6, which is the first term. That's a. Now we need r. How are we going to find the value of r? We are going to take the same value of 3 and substitute it there in the place of x, where our constant ratio r is actually located. So we're going to do the same thing and say r is equal to, in the place of x, 3 minus 1 over 3. What's 3 minus 1 in the numerator? 3 minus 1 in the numerator, that gives us 2 over what? Over 3. Alright, this value of r, which is 2 over 3, that's not 66666. That value is a value that is between -1 and 1. So it is basically really values of x that are between this -2 and 4, which will give us values of r, the constant ratio, that are between -1 and 1. So truly our r value is 2 over 3. For a series that converges, r must be between -1 and 1. This is something you need to really tune into, guys. It wouldn't make sense if when we substituted 3, we got a value of r that was not in this interval, because that would mean the series is not converging. For a series to converge, the value of r must be greater than -1 but less than 1. That's what 2 over 3 shows. It's a value that is between -1 and 1. Now we take the a, we go and substitute. We take the r, we go and substitute. Then we use our calculator, guys. Just our calculator. And we plug this in and get the answer. Simple as that. So I'm going to say 6 divided, right? 1 minus 2 over 3. Okay. The answer is 18. That's the sum to infinity, as Ritabile confirms in the comment section the second time now. Okay, Sum to infinity is simply that, guys. Sum to infinity can only be calculated, guys, when r is between negative and 1 and 1, which means, in other words, that a series needs to be converging in order for us to be in the position to calculate the sum to infinity. Listen to what I'm saying there. The value of r must be between negative 1 and 1 for us to calculate the sum to infinity, because the sum to infinity is calculated for geometric series that converge. Okay? Yeah, and if you guys can stick to that, we will be okay. Okay? We will be okay. Okay? Alright, let's continue. Thank you, Sekhametsi. Sekhametsi is like really unleashing them gifts. Thank you so much, my sister. I don't want to say my brother again, lest you shambok me again like you did the last time in the live. Calculate. Okay, let's do these two. Sigma. 20 at the top. Obviously, substitution of 20 into the expression means our last term. P is equal to negative 2. Substitution of negative 2 into the expression, that is the value of the first term. Substitution of this means the last term. Substitution of that means the first term. That's something you need to know where sigma is concerned. And obviously, if they say calculate, it means we need to calculate the sum of this entire what? This entire series. What type of series is this? Okay, 7 minus 4p. 7 minus 4p. 7 minus 4p. What type of series? Look at this, guys. Immediately you should be able to know what type of series is this. Geometric or arithmetic? You should know. Ritabile, very good. Arithmetic. Why did you know instinctively that it is arithmetic? Okay. Why did you know instinctively that it is arithmetic? Look at P. Look at the variable. Where is it? It is multiplied to a coefficient. So that speaks of linear. Linear sequence is the same thing as arithmetic. Okay, so take note, guys, whenever the variable is placed next to and the exponent of the variable is 1, then that means that is a linear. The variable in the numerator placed next to a coefficient or as a single alone term. Okay, whenever this variable you have there is alone, exponent is 1, then it says that it's a linear sequence, and a linear sequence we know is arithmetic. Sorry, not sequence, series. Okay, linear means arithmetic, arithmetic means linear. All right, but if there was a variable p in the exponent, then we know that is geometric, you see. So please take note of these things. The problem we had done earlier on, the variable was also next to a coefficient, but then the variable had an exponent that was 2. Okay, that exponent 2 does not mean linear, it means quadratic. So that's why we were able to see that this one, there's no formula for it. So we need to actually use our logic and our common sense and substitute and simplify. Does that make sense? So take note, guys, this is actually your general term for the given series. Okay, so the first thing we usually do when we calculating or simplifying, obviously, you know, such, is step 1, let's get the series. Vinny, go December. No. Vinny, I can see Vinny's head. Like Vinny comes into the live by mistake. He looks at the live screen and he sees the maths happening and he's like, come on guys, I'm still enjoying my time. And when I want to do this maths for December, no. Yeah, Vinny. Hi, Vinny, change your ways, my guy. Change your ways, my guy. Okay, anyways, 20 p is equal to -2 in the here. So this is for substitution for our first our first term. Then 20 is our substitution for the last term. Are we together? So let us go ahead then and substitute to get the terms of the series. So we first substitute -2 to get the first term. 7 minus 4 into -2 plus 7 minus 4, the consecutive value after -2 is -1, plus 7 minus 4, the consecutive after -1 is 0. Okay, we at least need the first 3 terms. So we have 7 plus 8 plus 7 plus 4 plus 7 minus 0. We have 15 plus 11 plus 7. These here, guys, are what we call our first 3 terms in the series. We need those first. That's what we start with. 2, let us figure out the number of terms that we need to be adding, because we are going to find the sum of that particular number of terms. How do we get that? We take the top number here, we subtract the bottom number, which is this one, then we add 1. So in other words, we are going to say 20, there's a minus sign there in the formula, minus 2, because the p here, the value here at the beginning is -2, plus 1, which gives us what, guys? 20 plus 2 plus 1, which is actually equal to what? 23. So our n is going to be 23 for the sum of the number of terms. We are going to calculate the sum of the first 23 terms. Are you with me, guys? Hey, I hope you are feeling me here. This is an arithmetic sequence. The formula number 3 that we are going to be using is either Sn is equal to n over 2 into 2a plus n minus 1d. We can use this formula, or we can use this formula. It's up to us which one we want to use. This one will be used only if we have the value of the last term. And guys, we know that the value of the last term can be found if we take 20 and substitute into the formula. The value of the last term plus ... plus the last term. We take this 7 minus 4 into 20 and we get the value. 7 minus 80 is -73. I repeat. You substitute in the place of p, you substitute 20, because remember, guys, I said to you, substitution of p is equal to -2 gives you your first term in your series. Substitution of 20 in your series gives you the last term in the series. Hi, we are moving now. Hey, we are moving. Walala, wasala, wasala, walala. You know? We are moving now, guys. We are moving. Walala, wasala, wasala, walala. You know what I mean? Hey, I'm telling you the things here. I'm telling you the tellings. All right. So I repeat once again. The 20 at the top is the value we substitute in the nth term so that we get the what? The last term in the what? In the series. The p is equal to -2 is the value that we substitute in the nth term to get the what? The first term in the series. Each subsequent value after -2 that we substitute gives us the next. Okay, we substitute -1, we get the next term in the series. We substitute 0, which follows -1, we get the next term in the series. All right. And of course, the very last term in the series, which is further along, is when we substitute the 20, which is at the top there. 7 minus 4 times 20, which is 7 minus 80, gives us -73. Okay, are we together, guys? So all in all, that's how we get the terms in the series. The first 3 and then the last one by substituting the top value in the nth term. Then we need to establish how many terms there are in this entire series. How do we do that? We take the top value, which is 20, which indicates our substitution for the last term. We subtract this value that we have here, which in this case is -2. Then you add 1, guys. As per culture, you add 1. You get 20 minus -2, which is 20, plus 2, plus 1, which is 23. So that means I am calculating, and I'm going to calculate the sum of the first 23 terms. You choose a formula. You can use this one. This one does not need the last term. It just needs n, it needs a, and it needs d. This one, where you have the last term, just needs a, n, and l. Doesn't need d. Both of these should give you the same answer. Ritabile has already said in the comment section the answer is -667. Let us check if that is the case. N is 23. A is 15. D, if I'm using this formula, is going to be T2 minus T1, which is -4. T3 minus T2 also gives me -4, so D is -4. So N is 23, A is 15, D is -4. And if I'm using this formula, my L value, just so you know, is -73. So you must decide which formula you want to use. Guys, I want you guys to confirm for me if you use these values, A, N, and D for this formula. Do you get the same answer if you substituted A and L and N in this formula? Is it really -667, as my dearest, amazing friend Ritabile has said in the comment section? Do we agree? Do we fully and completely agree? And do you guys have any other questions? All right. This is simple and straightforward, guys. How we are able to get the sum of, in this case, the first 23 terms. We find the first 3 terms in the series, substituting this for the first term, and substituting the consecutive values after -2, -1, and 0, so that we can get the first 3 terms using this formula. There the first 3 terms are. If you want to know what the last and final term is, you say plus ... and then you write a plus there at the end. You substitute 20 there, you get the last term, so that you know what that is too. Okay? Then You want to know what the value of n is, you take the top number minus this bottom number, you add 1. You get n. Then you get a, which is the first term, d, which is the constant difference, l you already have, which is negative 73. Then you choose which formula to use to find the sum of the first 23 terms. So this one, thank you Ritabile. Hey Ritabile, you're very resourceful, you know, very resourceful. Thank you Ritabile. Gitabile, Ritabile, Gitabile. Yeah, Gitabile. Alright, so there. Yeah, okay. Ritabile is saying we get negative 667 for usage of this formula. If we did not use this one, we could if we wanted to use this one. I am just doing both, guys, so that we can be comfortable in knowing that it doesn't matter which one we decide to use. At the end of the day, it will yield the same answers. 15 minus 873. Okay, in this situation, 15 minus 73. Put that in your calculator, should get the same answer. Why am I saying minus 73? It's because a positive times another negative will give me a negative. So I'm not even going to waste my time there. Let's just quickly check the other one. That's 23 over 2. We put it in brackets there. Right, 15 minus 73. Close the bracket. We say equal. Still, truly the same answer. Okay, thank you, Ritabile. I think, yeah, Ritabile. Yeah, right. 12 o'clock just hit. Let me do the last and final one, and then, yeah, I will put this to bed. So guys, I will officially put sequence and series to bed for now. That does not mean that I'm not going to be sometimes revisiting some questions, especially like other questions that maybe I have not done before. I am actually going to continue with the next topic in the next live lesson, which means I'm going to jump into functions. All right, jump into functions, which is the next topic. And we're going to push functions, right? Start off with grade 11, so that we know what we should be knowing, all of us, and then get into the grade 11. Start first with covering the concept. No problems, just the concept. Okay? Just the concept of functions. Then after covering the concept of functions for grade 11, go to grade 12, and then we can start looking at exercise type questions and exam type questions. We'll do that, like I said, the next time. Thank you, Sekhamit. Yes, tomorrow, guys. Tomorrow is the day, you see. But I will occasionally revisit questions on sequence and series, you know. So like maybe in the middle of my lesson, I'll just grab, you know, a question on sequence and series and do it. So we are going to continue to kind of like have a bite every once in a while of sequence and series there and there, so that we do not forget what we did in sequence and series whilst we are doing functions, if that makes sense. And then also I hope you guys will continue to practice your sequence and series. Don't lose, you know, what you've gained. All right, let's do this last one. Find the value of p. Hey, do you see this? Find the value of who? Of p. If p at the top, if deal, okay. Well, thank you so much, Ritabile. No problem, no problem. Screenshot it and practice it, my dear. Thank you so much. It was such a pleasure having you. Thank you, thank you, thank you. Okay. Find the value of p. If p k is equal to 1, 2 into half to the power k is equal to 127 over 64. Okay. It's a nice problem, this one. Okay. I love the way it looks. and I like the way we can move with it. Okay, so let's do it, guys. P. So we want that top guy there. Okay, look at my nth term, right? The nth term is what type of series? What is it giving? Arithmetic or geometric? Yes, thank you so much. Geometric indeed. Why do we say geometric? Because this time round, our variable is an exponent. It is not a base, but it is the exponent. When the variable is not a base raised to the power 1, then we say it's geometric. All right. When it's not a variable, because if it was a variable base and it was to the power 1, then we would say it's linear, just like this one. Variable is a base and the exponent is 1. That means it's linear arithmetic. This one, the variable k is equal to 1, that's our variable. The variable is an exponent, so that means it's geometric. Okay, so that means we can find the first 3 terms of the series then. Do you see? First 3 terms of our series we can find, and we can find the value of what? Of r as well. Okay, yeah. So let's go ahead. First 3 terms. Substitute k is equal to 1 and substitute the subsequent values. You see? Do you see, guys, how easy this is? So we substitute 1. When I say 2 into half to the power 1 plus 2 into half to the power 2 plus 2 into half to the power 3. So that means a is going to be 2 times half, which is 1, plus 2 into half squared, which is 2 times a quarter, which is actually equal to what? A half. So we have a half, 1 plus half, plus 2 into 1 over 8, which is actually 2 over 8, which is a quarter. This is our series. 1 plus half plus a quarter plus dot 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 plus. All right. Which means we can go on forever. Okay. So that's the first step. Step number 1, find the terms of the series. Okay. Then from there, a is equal to 1. Since it's a geometric series, we can get r. Okay. Remember, r is t2 divided by t1. So in this case, we have half divided by 1, which is a half. All right. Same thing, a quarter divided by a half would be half. So all in all, we have r, we have a, then we need one last thing, n. All right. So step number 2, to get that n, we know we say top minus bottom plus 1. Which top? That top minus bottom. Which bottom? That bottom plus 1. So we're going to say p minus 1 plus 1. That gives us p. Okay. So in my head, I'm like, the sum of p terms. Okay. The sum of p terms. Yeah. But that entire sum, I know it's equal to 127 over 64. So I am going to look at r. R is half. This r, guys, is less than 1. And remember, we have a formula that we use when we are calculating what, guys? When we are calculating the values, when r is less than 1. So I'm going to choose that formula, and then I'm going to take it from there. So let's do this then. Sn is equal to a into r to the power n minus 1 over r minus 1. Let's just use this formula. Okay, so we know that Sn, or let me say Sp, is going to be equal to 100 and, is it Sp? Yes, is equal to 127 over 64. Wow, guys, it's New Year's Eve, right? Wow, yeah, today is New Year's Eve. That's great. It's crazy. Okay, Sp 127 over 64. All right, so this guy, DT is hilarious. Right, so let's go now and substitute here. All right, in the place of n, we are going to substitute p. In the place of a, we are going to substitute 1. In the place of r, we are going to substitute half. So let's go ahead and do this, guys. 1 into half to the power p minus 1 over half minus 1 is equal to 127 over 64. All right, we want the value of p because they said find the value of p, so p is our obsession. And of course we said top minus bottom plus 1 so that we could establish what the expression for the number, the sum of the number of terms, and it's the sum of p terms. Okay, so that's why we have Sp is equal to 127 over 64. All right, because we established the number of terms whose sum we need to find. The sum of p terms is equal to 127 over 64. Remember, sum of p terms is a, which is 1, r to the power n half to the power p. In the place of n, we will write p minus 1 over half minus 1 is equal to 127 over 64. Okay. Okay, so far are we good, guys? So far is things okay? Then we have half to the power p minus 1 over negative half, because half minus 1 is equal to a negative half, guys. Do you see that? Half minus 1 is equal to negative 1. Hope that is clear as well to all of us. Then this needs to go. The division of negative half needs to bounce. So we are going to multiply at the top by negative half, so that this negative half and that negative half cancel out. But a negative divided by negative is positive. But what we do on the left, we do where, guys? On the right. Okay, so we multiply by negative half on the right as well. And when we do that, okay, we are going to be left with half to the power p minus 1. Grab your calculator, you multiply 127 over 67. I wrote 67. Oh, sorry, my bad. Thank you for that correction, John. It's a bad error, right? Thank you, guys. Thank you. Hopefully, and I love the fact that you guys are seeing my errors. It means you are vigilant, you are aware of what's happening. Please make it a point that we exercise that same alertness and awareness as we do problems ourselves. Otherwise, thank you so much. I really love that. From the Queen herself, Baby Immaculate. 127 over 64. We multiply by negative a half. We get negative 127 over 128. All right, when we multiply by negative half. Okay, then we transpose this negative 1. So half to the power p is equal to negative 127 over 128 plus 1. So we are going to add 1. We get a positive 1 over 128. Okay, so far so good. Then (128) is equal to shift fact. I want to see in exponential form, what do we get for 128? We get 1 over 2 to the power 7, which in all honesty we can write as 1 over 2 to the power p is equal to 1 over 2. Now we can take out the exponent 7, because when the exponent 7 is applied to 1, it still leaves me with 1. 1 to the power 7 is 1. Any base 1 raised to any exponent will always give me 1. I apply that same exponent to the denominator, it gives me back that 2 to the power 7, which is the 128 that was in the denominator. What do you see, guys? Bases are the same. Half, half. Bases are the same. So what do we do to our exponents when the bases are the same? What will be the value of p? Because remember, we were actually trying to find the value of p by doing this question to begin with. Okay. So I hope you guys see what I've done step by step here. So therefore, the value of p, thank you so much, Queen, p is equal to 7. Right? Thank you so much. Really appreciate that response there. Okay. Yeah, Baby Immaculate is doing the things there in the comment section. So p is equal to 7. Sekhamiti, thank you so much for 4 of those, you awesomes. Really appreciate it. So p is equal to 7, guys. You're very well put, and simply put, that is the value of p. So if you can see, the skills required from the formula substitution to the end all have to do with algebra and simplification of exponents. When did my beloved grade 12, that is you, do exponents? In grade 11. It was in term 1. You did exponents and surds. So your skill level to solve exponential equations should be just good. You know, there should be no question about you getting to the answer. Algebra, applying your inverse operations, applying your, your algebraic acumen needs to be as good. So all in all, this is how we do this particular problem. Okay. Yeah, guys, I think that's pretty much it for today. Thank you so much for joining in. I would please implore all of you and encourage you to continue practicing, continue leveling up and improving your exponents, sequence and series, algebraic equations game. Right. Ngoma, it will still be 9. All right. I will definitely leave you guys, so that you can be able to say Happy New Year without me. I don't want you to be saying Happy New Year whilst you're still in the live. So maybe we'll keep it at just an hour from 9 until 10. Or let's say 9 until 10:30 tomorrow, so that you guys can say Happy New Year, not here in the live. You can say Happy New Year somewhere else. Happy New Year under different conditions. Remember, guys, that the lessons that I do here, I do upload them raw as you find them onto my YouTube channel, so you can rewatch sessions not seen here. That you may have, anything that you may have missed, you check it out there. So yeah, we'll start functions tomorrow, sort of like recap on grade 11, the concepts in grade 11, which is very important. Functions, guys, are easy. Your functions game needs to be top notch as well. Your grade 11, grade 10 functions game needs to be top notch, top level. Grade 12 is really straightforward, okay? Grade 12 is straightforward because in grade 12 you are just dealing with inverse functions, okay? And really and truly, guys, you're talking about your exponential function as an inverse, you're talking about your straight line function as an inverse, and then you're looking at your parabola, how you can express a parabola as an inverse function only if you restrict the domain of the function for your parabola. And that's pretty much about it when it comes to functions. Everything else that is important and crucial in functions is coming from grade 11 and 10. Which is why I'm saying you need to have your A game on for all concepts for functions, so that functions can start being one of those topics where you are able to easily get your 100% in, right? And guys, grade 12s of 2025 were given the hard bargain, if you ask me, when it comes to functions, because the questions that they were asked, a corner. Yeah. And you guys are the last cohort that is going to actually be tested under the same exam guideline that has been utilized for the past, I guess you could say, since 2014 or 2021, because the exam guideline is going to go under review now in the next year. And I think in 2027, the grade 12 cohort group is going to write their metric exam using a completely different exam guideline, which would mean that there's going to be new things featuring, or let me say maybe not new things per se, but definitely the focus of exams now will be different. What they are wanting to do is to depart from examining you as per previous groups have been examined, meaning you guys have an idea of the structure of questions that are going to be asked. They want to depart from that because they want to start testing your, they want to start testing to see if you can apply mathematics, in different scenarios that are not common, right? As the grade 12 cohort group, for instance, of 2025 actually experienced. No, Sekhametse, I doubt it if they'll add matrices, but if they do, then I guess it will be that committee that will actually review the things that will see if that will be necessary. I have no idea. What I do know is that the exam guidelines are changing for 2027. You guys are still going to use the exam guidelines that have been for the past couple of years, but the 2027 group of grade 12s is going to use a completely, I guess, a reviewed exam guideline moving forward. Okay guys, thank you so much. Have a good night. Please take care of yourselves, and practice so that we can win with the mathematics. There's just more problems I would have obviously done, because there's so much more, guys. I mean, really and truly, but similar type of questions, just so that we get that practice in. So you do it make it a point that you go past papers, guys. We have from 2014 end of year exams up until 2025 now, the most recent. So imagine if you could practice all the questions that have been ever asked for your end of year exam since 2014. You do the 2014 November paper, you do the 2015 November paper, you do the 2016 November paper, you do basically sequence and series for all of those papers. At least you will be really covering a lot of ground if you can just do that up until 2025. Then when you do the next topic, you do the same thing. Okay, you go through the 2014 paper, 2015, 2016 up until 2025. That will really boost your confidence. I can promise you that. You will really be ahead of the game in so many ways by doing that. So yeah, there's lots of questions that are available to be done. Yeah, that you can familiarize yourself. Okay, guys, thank you. Let's see each other again tomorrow. Right? Thank you. Bye. Baby Immaculate, I have no idea which app is best for practices because honestly, there are so many apps that are there. But yeah, people use different apps. I honestly, there's many apps. As long as you can find an app that can actually provide the actual past papers from 2014 up until recently 2025, and the memos are available for you to actually check out the minute you do a problem. Okay, bye guys, bye. Thank you again for the gifts and everything. Thank you for participating and thank you for being awesome. Actually, let me just do what I usually always do. So Hamid, thank you so much. You've contributed quite a bit of coins, diamonds, if you want to call it that. Thank you, Hamid. Thank you again. Thank you so much. I really appreciate you, dear sister, mother, everything. I really appreciate your valued contribution as well as just the gifts all the time. Really encouraging. Thanks a ton. Slash, thank you, Ayola Suka. Oh, Ayola, you were here actually. Hello, Ayola. Zala knowledge. It's always my brother. Baby Immaculate, amazing. Don't be Faith. Don't be girly. It's nice having you. Nosy, awesome. Oh, we have the fan of Matters a game here as well. Oh, awesome, man. Me. Mpumza Nom. I've got a fan. I didn't know that. Nom. Oh, Nom. Good seeing you. Kamo Khelo Mapanga is good seeing you, buddy. DK10. I don't know if it's Togieda or Togieda or what. Might be saying it wrong. Kenny Brew, Adise, Belede, King Charles, Kaboyelo. We've got Breaky, SK Za. Verena, Sia, we've got Sepi Sotobahale, we've got Roniwa, we've got Stanmore, Bekanwane, Kenny, Bright Shake, Tando, Letaba Mkhotwane, Tulisile Lubuzo, we've got Mediclinic Cape Town, user 493124, I'd say your entire word number, but yeah, I'm on the 021, Abu Bakar. Hanif edits. I go by Joe. You do. Les Showstopper. We got Scarly. We got Dusty SA. King Ghost. Tugi. Sesi. Date. Happy Lesibia. We got Ndondo. We got Koboka. We got Isaac Tove. We got Yanga. Chwe Mbeni. Kumo and W. Wase. Guys, thank you to all of you. You were great, amazing. Have a great one. And thank you again for the gifts. Thank you. It means the world. Thank you. Have a great night and see you again tomorrow, 9 p.m. Same time, same place, same condition. YouTube handle, link in my bio, good sir, or good ma'am. Link in my bio. Just go to my bio, you'll see the link. Click on the link and it will send you to my YouTube channel. It's at Maths is a Game. 5 to 7. That's basically the link. It's Maths is a Game is together. It's all together, man. And then 5 to 7. It's all together. Like you 5, a dash, and a 7. Or is it a hyphen? Yeah. At Maths is a Game 5 to 7.